So we can start the recorder. So Corentin, whenever you want, I stop sharing my screen and you can share yours.
So good afternoon, everyone. I cannot share my screen, so
you cannot share your screen.
Yeah, the host has disabled participant screen sharing. Sorry. Yes, and thank you very much for your patience. I'm the one who's supposed to come from Switzerland here, and I'm the one arriving late. Maybe to my defense, the only thing I can say is that I am on time, but on the wrong time zone. But I'm very sorry about that.
If I make you as a co-host,
that should work. Yeah.
Perhaps, right? Let me see. Can you try?
Yes, that works.
Yes? Okay, good.
All right. Do you see my?
It's coming up. Just 1 second. I don't see it.
Maybe it just needs some time, because I saw a message that he was about to share. Sometimes it just takes a little while.
All right, let's try again. Supposed to, yes, okay. All right, do you see my screen now?
Not yet.
Not yet.
But this says that I starting screen sharing.
Yeah, give it a minute. It sometimes just takes a while. What about emailing the presentation and Ornella can show it? I can't think of any other way. Sorry, everyone. I think until now our seminars have always gone off completely without a hitch. So I guess all the sort of bedevilments have come to roost today.
Corentin, are you trying? Corentin, you're muted.
Yes.
Anybody who's listening to the recording is going to have an interesting time.
Let me try again something.
Yes.
Okay. So that should work. I guess my screen was too big for Zoom. All right. So elements. This is the topic that I will share with you. And maybe what I'm doing is to hide this, okay? And the results of a life cycle assessment of 1,200 recent buildings, housing buildings in particular here, built in over the past 5 years in France. So those are all recent buildings. So on top we see what we call the operational carbon. So all the emissions that are related to the use of the building for 60 years during the lifespan of the building. So heat from the everything related to the heating, to the cooling, to the use of electricity in the building, for instance. And then below that, so the bottom part shows the embodied carbon. So all the emissions related to the production of the construction materials, the construction, the maintenance of the building, and the end of life. And there are a few conclusions that we can draw from this graph. The first one is that there is a huge disparity if we look at the operational carbon for buildings. On the left-hand side, we have probably buildings with very poor installations, very bad heating systems, and so on. And on the right-hand side, we have what we would call zero energy buildings. The second conclusion is that there is no correlation between the top and the bottom part. And so that means that the architects, designers, the engineers, the owners as well, who wanted to reduce the operational footprint and the operational carbon of their building, didn't pay attention to the embodied carbon. So they tried as much as they could to reduce those operational carbon, but didn't manage to do it for the embodied part. So what's the reason? Is it because simply they didn't compute that carbon? And probably yes, that's one part of the reason. And maybe, I mean, the second answer could be, is there because there is a lack of capability. So they didn't know how to reduce this embodied carbon. And actually we can ask ourselves that question. So is it possible to break this threshold that we see on the bottom part here? So this line that we see here, is there a way we can actually break it and reduce this embodied part as well? Because if we continue building and renovating buildings with bad operational footprint, then yes, it's fine if the embodied carbon is big because it's only a ratio of it. But now if those are on the we are demolishing buildings for various reasons. All the time, everywhere. This is just a map of all demolitions that happened in the past 20 years in Switzerland, which accounts for 70,000 buildings. And the big issue with those demolished buildings, besides the fact that, of course, it generates waste that and that's becoming an issue. What's annoying with those demolitions is that we are demolishing those buildings because we don't need them, and it's not because the materials in those buildings has degraded. So we don't need the space they offer, those buildings offer at that location at that point in time anymore. But still, the materials are of very good quality. The slabs, the beams, the columns could still perform for a longer time. And that's the main issue that is addressed through reuse. So, I mean, reuse, I'm pretty sure that in the center, since you all work on circularity, you know what I mean here. So it's not about recycling and remanufacturing a new material out of existing waste. Is really about reusing the components, the pieces as they are given. And here is just an example showing that. So it's a bridge that was built in 1810. 1 century later, the owners decided, so the city decided to replace it with a bigger bridge, a taller, wider bridge. And a few months later, monks from the village nearby actually reclaimed the posts and beams that we have in this bridge. So those posts that we see here are actually reclaimed here in order to build the barn that we see on the bottom of these slides. And if you look at the cuts that we have here in the columns, those are the precise cuts that were needed once the posts were in the bridge. So that was a few months later, and this barn is still standing today and still in use. And so what we have today is a 100-year-old building that is made with 200-year-old components. And that's really the spirit of reuse. It's to have building materials that last longer than the buildings they are part of, because we know that unfortunately, I mean, the space requirements evolve over time, so there will be a need to transform, demolish, or replace, or just adapt buildings, but it's not an excuse to discard the materials inside those buildings. So yeah, here are some close-ups with those marks. So it's also very interesting because in terms of heritage, we can actually see the traces of the previous uses, and the materials tells a new story, a different story that goes beyond the lifespan of the building. And so when you reuse, of course, that brings a few environmental benefits. And here are just a few of them. So we've shown with recent studies in our lab, but also other researchers elsewhere has come up with similar numbers, that reusing components can save up to 70% of greenhouse gas emissions compared to a new product. And that's especially true if we are considering load-bearing components, so the heavy ones, the large ones. And then reuse in Switzerland could also avoid up to 40% of waste. It's only 40% because 50% in those waste are actually soils that are moved from one site to another one. So those are not reused, and that's why it's 40% here and not 80%. As well, so reuse could, because there are limitations between offer and demand, you can only reuse what we are demolishing, and so reuse could avoid 10 to 25% of extracted materials. As I showed, reuse is also a new way to deal with heritage from a cultural point of view. And then last but not least, and the main reason why the EU is pushing for circular economy, it's because it's creating jobs that are local, non-externalizable, and renewable, so sustainable jobs. Today, reuse in architecture, it's considers mainly not load-bearing components, so the easy materials to reuse, but those are not the materials that will allow us to save CO2 emissions, unfortunately. And so if we really want to reduce CO2 emissions, we need to reuse load-bearing components. There are more and more examples of applications, but still it's a niche practice. Here is an example of an extension done 2-3 years ago in Switzerland, where the full steel structure has been reused for the extension. And so in the structural exploration lab that I'm leading at EPFL, we are actually working on showing how reuse could be more implemented and also optimized. And we look at it from a design point of view, because for designers, reuse implies a change of paradigm. So in the conventional design, and let's say that designers would first start with the shaping of a general form of the structure, and then little by little, after subsequent structural analysis, then the designers will have a precise understanding of what should be manufactured and with what properties. So what should be the lengths, the materials, the compositions of the materials in the structure. Now, if we start from a stock of materials to reuse, the story is different, because the materials is given. So we know the geometric properties of the materials. We cannot change the components, sorry, we cannot change the materials. Their mechanical properties is given. And the design challenge now is to find the best shape, the best structural shape that would reuse those components. That simultaneously there are three questions to solve. So if we take this example here, the first question is what members to take from these pylons. So what are the members that are worth being reused? The second question is where to put those members in the final structure that we see on the right. And the third question is what shape to give to this final structure. And all this could be transformed and written down in a mathematical way, and so could be optimized, which is actually useful because in reality, every time we are reusing, the pieces that we can reuse come from are very diverse. So it's not like we have 200 times the same components, but it's things. And so, as I said, the problem could be optimized, and we applied regular optimization of algorithms that we actually adapted to the question of reuse. So starting from ground structures, we can optimize for minimum weight, but also for minimum cutoff of the members. So how to minimize waste, for instance, but also how to minimize CO2. And those are algorithms that can be used for trusses, but also for frame structures as this one. And what's interesting is that all the time in all case studies that we are implementing, we are always showing huge environmental impact reductions. We're in a range from 40 to 60% compared to, for instance, if the structure was in steel compared to recycled steel. And also what this graph here is showing is that if we really want to reduce the environmental impact to a minimum, the goal is cannot be to reuse 100% of the members, but we should allow some members to be manufactured for their proper use. And the reason is that when we reuse, we cannot optimize the cross sections, and so it means that because they are given, so it means that every cross section is a bit oversized, and that increases the weight. That increases. I mean, it's not optimum for transport neither, and so those members that are too oversized should be replaced with newly manufactured material. If you're interested in that, so we have this plugin for Grasshopper that is freely available, of course. It's been used to design the facade that we see on the right, facade made of components coming from electric pylons, actually. All right, so the second part of this presentation is about the concrete. It's the big elephant in the room. Production of cement, as you may know, is responsible for 8% of all CO2 emissions worldwide, and it's also concrete waste also represents up to 30. we have to find a way to reuse concrete. Currently, the best end of life for concrete, as most of you probably know, is to recycle the aggregates in new concretes. It's great because it avoids the extraction of natural aggregates, but it doesn't change anything in terms of CO2 emissions. So what we are suggesting here is that before we crush the concrete, we actually operate a clean deconstruction, employing, for instance, diamond saws, as we see here. Those are techniques and technologies that already exist and are used on a regular basis, mainly in densely urban areas. So we wanted to start by showing that, so 2 years ago, showing that it made sense to reuse those pieces of concrete. And so we built this prototype here. For that, we partnered with a deconstruction company who actually was commissioned to remove walls from this hotel who was only 10 years old. And they had to remove walls from the basement. So we gave the dimensions of the pieces we wanted, and we cut them, and then we drilled holes inside those blocks in order to have enough room to put a post-tensioning cable. And again, I mean, a similar story. Whenever we want to reuse the blocks here, have all a different geometry. So there is inaccuracy. There is you have different dimensions because of the way the concrete was cast 15 years ago, but also because of the way the concrete is cast, which is not precise neither. And then drilling the holes is not, and the position of the holes is not guaranteed neither. So there is a variety of dimensions, and this cannot be avoided, but we can anticipate that. So as designers, we can make sure that, for instance, that the blocks are ordered in a particular sequence, such as to minimize the variations between any two blocks that are next to one to another. And also the other strategy here, in order to deal with this given variability, was to have regular mortar joints in between the blocks that allowed us to visually decide the distance between two blocks, and so every joint has a different thickness, and what matters, and it's not an issue. It's and what matters is the overall geometry anyway. So here's some. I had to put some graphic statics diagrams for Ornella, so this, you have it here. We used it for sizing the post-tensioning cable inside the arch, so making sure that the arch works in pure compression all the time. And in the end, what we have is a concrete footbridge that is just as strong as new concrete. So we have all the nice qualities of concrete, but we didn't cast any concrete in order to build it. And if we do a life cycle assessment and compare this recrete arch with other variants for footbridge with the same span and the same load cases, then we see that so we're using concrete divides by 3 the global warming potential of the arch compared to one that would be cast in place with recycled concrete, and would divide the global warming impact by 3.5. Then we see that the global warming potential is just as high. And actually our recrete arch was not that optimized, because what takes the most in this LCA, so it's this thing here, which is the impact related to the construction of the formwork, the timber formwork that we use to put the blocks on to. And that formwork, it was made out of new timber, it wasn't reused and so on. So that's huge impact. And then the other big source of impact is related to the transport of the pieces, because there was something like 70 kilometers from the demolition site to our facilities. And so that means that we can, there is room to further reduce the impact of this reused concrete, and eventually realize that maybe reused concrete is as green as timber, and timber is usually seen as the most sustainable structural material of all, and maybe here reused concrete is a good contender to this. And again, I mean, so of course we don't know how, I mean, everything about those pieces. We don't know with precision what type of concrete it is. We don't know if there are rebars and so on in that, but we can, using existing tools and assessment methods, we can actually have enough confidence in order to build this bridge. What's also interesting is that in order to make it work, we had to work with these 3 companies, and those are companies that usually don't work together. So the first one is a demolition company. So they work for demolition. The second one is a construction company, and the third one is a maintenance, so it's a structural maintenance company. So those are 3 different fields in structural engineering that usually separate, and they work in silo. And here we show that in order to reuse those pieces, we have to bring the expertise from these 3 different fields together. So from demolition people, construction people, and maintenance people. Later on, we also improved the footbridge with other reused materials, and now the bridge is actually in use in the Alps in Switzerland. Just to show how, and to prove that the concrete reacts well, even if it's used outdoors. So after that, I mean, we knew that this wasn't the first application of reused concrete, but we wanted to know what was out there, what was done before us. And we identified many applications of reuse of prefabricated concrete. For instance, this one, where the building on the left was fully dismantled in order to build the new buildings on the right. This was back in 1986 already. And then other examples like this one made by researchers in Berlin. Again, prefabricated concrete, this one as well in Boston this time. And so all in all, we collected 77 precedents of concrete reuse. And I'm showing, it's a recent paper, and I'm showing it because whenever we had records related to the environmental impacts, I mean, they showed that it made sense, more than sense, to reuse a concrete. So compared to the conventional construction, you can see savings of between 40 to 90% even. And also what's important are, of course, costs always. And so this is what you see on the right-hand side. So whenever the cost comparison was recorded, what we see is that in some cases, it was beneficial. So people made money by reusing concrete. And in all cases, this is when the people building the new building are also owners of the building to demolish. And so that means that they can optimize the logistics, and also they don't need to pay for the waste out of the demolition building. Here is, I have a few slides, 4 or 5 slides here. So here is a recent study made by a master student here at EPFL, where she wanted to see how we can actually optimize the cut of slabs in order to reuse them and build a new building on the right. So the footbridge that I showed was the low-hanging fruit. So we used the compression strength of concrete, but we didn't reuse the now. If we want to reuse the slabs, we have to also reuse the rebars inside those slabs, and the question is a bit more complex. And so what we have here on the slide, so you see the two source donor buildings on the left, and the colors that we have here are actually they characterize the bending strength of the slabs parts. So every color means a different strength in X, Y directions, and that's because of the reinforcement bars that are present inside those slabs. And then on the right we have the new buildings, and the goal of the optimization algorithms was here, so as I said, to find where to cut those slabs, how to rearrange those slabs, how to flip those slabs if needed, how to rotate those slabs in order to build the new floor that we have on the right, while minimizing the additional strengthening that we would put on those slabs. So here the idea was to wherever it's needed to add an extra layer of ultra high performance fiber reinforced concrete, and those are the shades in gray that we see on the right, in order to make sure that the old slabs could withstand the new loads in the new buildings, as well as the new spans that we have in the new building. Additional to that, there is a need for developing new construction details. We also made sure that the bracing system, so that we see on the left, could reuse walls. So with horizontal, with struts, compression struts here in the walls, and then you see here the strengthening that I was speaking about in UHPFRC, and then shear connectors in between slabs on the right. Again, if we do a life cycle assessment and we compare this in one story made of reused slabs, walls, and bracing system, and we compare it with a conventional system, we see savings of up to 60% in terms of global warming potential. So now what do we do? The goal is really to convince the industry that not only it makes sense to reuse slabs from an environmental point of view, but also from an economical point of view. And the only way to do that is to work with the industry and actually build a real building out of those reused slabs. And so this is briefly what is presented here, where slabs from the donor buildings on the left will be reused to build the buildings on the right. The idea here is to avoid any additional strengthening, so no UHPFRC where needed. So we really reuse the slabs as they come from the donor building, but they are supported by a regular all right, so this is it. I'm happy to answer any questions you may have. Thank you very much.
Thank you very much, Corentin. Excellent presentation. I think there is a lot of that you have discussed, and I'm sure there will be question in our chat. So if anybody wants to raise their hand, and we can discuss with Corentin. Okay, so there are no questions. Okay, Bruno, do you want to speak up? You are in another place. Okay.
Okay, yes, I can read it. So the question is, Bruno's question is related to durability.
Yeah.
So I show that some assessment was made in the concrete, ribbon hammer and so on, but also wonder if any other evaluation or characterization was made. Also, will the service life of these elements will be the same as the new one? So yes, I mean, those are questions that I didn't address at all in this presentation, but we have a strand of research directly related to that. And maybe I have it on the next slides. No. So the first, before reusing, before deciding whether slabs will be reused or not, the first thing to do is to assess whether it makes sense to reuse those slabs or not. And so for that, we are developing protocols and reusability assessments that look at the quality. So through visual inspection, what's the quality of the concrete? They also look at the use class of the concrete before and after the reuse. And they also look at the potential strengthening that would be available. And in terms of durability, whenever so if the concrete was inside the building, it means that the concrete was protected. So there is no leakage, there is no humidity issue. And so there is no carbonation issue neither. And so that means that that concrete of buildings, because it was protected by the envelope of the building, is still of a very good quality. And that is not the case if we want to reuse the concrete that was let's say on the envelope, just because it was subject to weathering. But yes, I mean it's a question that is there, but we don't see it as a real barrier. It's something to take into account, but it's not a barrier for reuse. And now the second part of the question was related to the service life of the elements. I mean, we can ask ourselves, what's the service life of a newly cast concrete? Is it 15 years? Is it 60 years? Is it 200 years? If it's well protected, if it's well done, I mean, it's the fact that we are demolishing buildings now that are only 15 or 30 years old means that the concrete still have a long service life ahead, and we are capitalizing on that. But I mean, maybe the other part of the answer is that there is still research needed to properly characterize this. And in order to implement maybe those questions into codes.
Thank you, Julia. You raised your hands.
Yeah, yes, thank you, Corentin. That was a really amazing presentation, a very ambitious and impressive thing to achieve. And so my question is a bit cheeky, because in a circular economy, things are supposed to be in cycles, in infinite cycles. Ideally. So do you see these elements as having another life after the new use?
After the new reuse?
Yes,
Yeah, sure. I mean, so so that the example where we put UHPFRC in order to strengthen the pieces, and we're gonna have a hard time to reuse those pieces again.
Yeah.
Or at least we didn't address that question at the time of design. For the other examples, so the last one where concrete slabs would be put on top, I mean, as simply supported slabs on top of two reused steel beams. This is a fully reversible system. So those pieces, they can be, I mean, in 10, 20, 50 years from now, they can easily be disassembled and reassembled in new layouts. So yes, I mean, there is every time we design something new, of course, it should be done as we're following design for disassembly methods. But currently, we believe that most of the focus should be on reusing the existing waste, because there is even if it's not reused and reassembled in the design for disassembly way, it means that we are avoiding the manufacturing of new materials, and so any waste that is reused is something. I mean, it's good. It's something to do.
I have to agree with that. Yes,
yeah.
thank you.
And to the first part of your question, I don't yes, the perfect circular economy means that it's reused over and over and over with no downcycling, but that doesn't exist. I don't think it's ever possible to assume that this perfect circular economy is something feasible, but that's up for discussion, I guess.
Yeah. Well, I think there is cascading as part of circular economy as well. So yeah. I think, I mean, it would be the same with timber, yeah, well, and to different levels. And I guess it's finding the appropriate degree of, you know, how much work you want to put into the eternal loop is, yeah, as you say, an open question. Thank you.
Yeah, thank you for the comment.
Mish.
Hi, thank you, Corentin, for the presentation. I was really interested in your kind of findings with the cost benefits of concrete reuse in the slide you showed, and you mentioned that kind of one of the contributing factors is if the demolition company was the same as the construction company, so that kind of reduces a lot of the overhead. Did you find there were any other kind of factors that affected the cost benefits or like premium? And specifically, I was wondering if, you know, the types of connections and how the original structure was built, does that have an impact on the final cost?
Yeah, no, thank you for the question. So probably I went too fast, but when there are savings is when the owner of the new building is also the owner of the donor building. So it's not the demolition or construction company, it's really the owner, because I guess it's also the case in the UK. Whenever someone wants to get rid of her building, he will have to pay just for the disposal of the waste, and that's a lot of money. And so if we take this, so reuse avoids wasting that money, so that if we take that into account, then yes, it's beneficial. But it's really needed, because if we are not putting those disposal costs into the equation, then building with reused components is more expensive than building with new components. And yeah, so really the disposal of the waste is the main factor, but also just logistically, if someone can adjust the planning of the deconstruction with the planning of the new construction, then it means that you can minimize the need for storage in between the two between the deconstruction and the construction. And again, there you can save money if you are if it's usually, and it's in Switzerland at least, there are what we call big real estate owners, and they have plenty of buildings, like hundreds, thousands of buildings in various cities, and so there is also they could also make sure that they so manage their assets in the long term, and making sure that transport distances are minimized from the construction sites to new construction sites. Yeah.
Thank you.
Yeah, thank you.
Excellent. Saskia.
Hi. This might, well, I know this is a bit of a boring question compared to the very exciting things you've just spoken about. But, do you know if there have been any problems with the property developers getting insurance for the new buildings that are built with reused components? And where does the liability of the materials like land once it's been through this kind of different logistical supply chain?
Yes. Probably that's the main barrier at the moment, is that insurers, they are not used to this idea of reusing components from one building to another one. I don't think they are not willing to do it. I don't think they are not capable of ensuring such processes, but it's something new, so probably that's it takes time. So what, yeah, I mean, there are different things in your questions. I mean, at least in Switzerland, the codes are such that what matters is the designer's confidence in the new structure. And so if the engineers, for instance, they are already, I mean, if they can get enough confidence from the donor building, so the type of concrete that is there, do all the surveys, the mechanical testing, destructive and non-destructive testing on those existing concrete structures, then I mean they will be able, they should be able to build enough confidence in the old structure. And then if they also have control over the way the slabs or the walls are cut, and if they also have control over the way those pieces are transported from one site to another one, control over the way they are repaired if needed, and the way they are put together on the new construction site, then I mean we believe that there is no big risk. I mean they are not taking extra risk by reusing pieces. They know I mean they have a sufficiently good knowledge about the mechanical properties of the pieces to reuse. They know what happened from the deconstruction site to the construction site, so it's not additional risk. At the moment, the insurers, there is someone to pay for for those insurances, then the insurers will provide the insurance. And then, but it's really country dependent. I'm not familiar with the context in the UK. I know that in France it's way more difficult because everything is I mean, you need certificates for whatever materials you want to put on the market. Everything should be done according to standardized protocols and so on. So it's a bit more complex, but again, I mean, fundamentally, reusing a piece, whatever, if it's timber, concrete, or steel, from one building into another building is not that different than reusing that material on the same building. If you are renovating a building, if you are renovating an old church that is 600 years old, if you are renovating a 50-year-old structure, I mean, you also need to assess the quality of the existing material, and here it's not, and that we can do, and that we have. I mean, the liability issues are solved already, so it's not that different than that. So in situ reuse is not. Sorry, component reuse is not that different from in situ reuse from a liability point of view, if we have control over the deconstruction, transport, and reconstruction.
Yeah, I completely understand that. Having done a lot of refurbishment projects in the past and working with a lot of old materials, and I agree with you that it's no more risky. So is it more a mindset shift the insurers will just have to get used to?
Yeah.
Yeah, okay. Thank you.
Thank you. Thank you.
Thank you, Corentin. I also agree with that. Although I think it's not that straightforward. So really industry needs to change the mindset to let that happen. I think that similar to this, or as a follow-up of this question, Nikitas, are you there, Nicholas? Or do you want me to read your question?
Yes, I'm here, and I can say my question. Great presentation.
No.
Great presentation. Thank you very much for your presentation. Basically, what I wanted to ask is, like, I can understand, doing this low level, I will call them for me, checks on strength and some like sample testing. But what about the full validation of the structure that you build? And such full validation can be achieved through model updating, through full-scale testing, through dynamic properties matching, through stress level acquisition. So have you done any of this, more detailed level, monitoring that can ultimately also talk to you about the fatigue life, because ultimately, like, the service life is governed by the fatigue like you have embedded within your structure. So what about this part?
Yeah, so the short answer is no. We have not done it. At EPFL, there is another lab called ResLab who is doing it for steel structures. So checking those fatigue constraints, I mean, for designers when they want to reuse steel beams and columns. So yes, we are, I mean, for us, we are okay with the low level things. Also because in the end, let's say the connections that bring those reused materials together, they are quite conventional. And the reused, let's say, concrete slab is not that different from a precast concrete slab. And the same with timber and steel. So yes, there is a potential to get more knowledge about the specifics of reassembling those old pieces together in a new structure. And see how it behaves in a more complex way. But then for designers, for most of the application side, we don't expect it to be critical. That's the short answer. But yes, I mean, go ahead. I mean, there is a potential for research there, and I don't think we are going into that at the lab. So yeah.
Thank you so much. Any more questions? Can I ask you one, Corentin? At the end of your presentation, you presented the building, where you are going to reuse the slab. So for that building, have you been working on the structural design of that? So how has been the process? How straightforward, what were the main challenges there? Yeah,
so we are there as a consultant, I would say, circular load-bearing structure consultant, something like that. So the owner is the canton of Basel, which Baselstadt, which eases the procedure because, again, they are owners of both buildings. But then we are providing, so we've been working on assessing the reusability potential of the existing structure. So going on site, doing some ground penetration radar assessment of that concrete to get an idea of just the reinforcement that we have inside those slabs. So we are providing those reports, and then we are also providing an external point of view on how to reassemble the pieces together. But I mean, most of the work is done by regular professional engineers with their office, and they also realize that it's not that different for them as long as they know what they are cooking with. I mean, it's a new ingredient, but it's a spice is still a spice, and pasta is still a pasta. If I can make some correspondence here, but yeah, so I mean they can still it's not that new for them. They have all the tools. It's really
okay. But I imagine that will demonstrate that it is so that there is some basic knowledge that needs to be done about the existing building, but then it can be implemented in a normal design process. And I think that the fact that you guys are working on that to show that that is feasible in a conventional kind of approach, I think it would be important to show that the capacity.
Yeah, indeed, and that's also still an open question at the moment, because I mean we see that people who reuse components, they work differently. So do you start by just designing your building as usual, and then you say, oh, I need this material, so let's start looking for that material in the city? Or do you start from the other way around, saying that, well, we have this potential here of this building that we have to demolish. What can we do with it in a new building? And then in between those two extremes, you have, I mean, what we see is that, I mean, what's interesting is in between those two extremes, where you assess so the reusability potential of pieces in a step by step. So as you go further into the design process, you go further into the type of assessment that you have to do and the level of details that you need to know regarding the existing the quality of the existing pieces. Yeah. So yeah.
Thank you.
Thank you.
Yeah, so I think, yeah, Julia saying we probably need to start to close. So thank you so much. Apologies for the time difference issue at the start.
It's my fault, sorry.
No worry. It
It was worth the wait, definitely. Yeah.
Yes. All right.
We would have waited even longer, I think, for something that good. Yeah.
Thank you very much.
Yeah. So it has been really a pleasure. I'm sure, Corentin, if you are interested, I'm sure we will have other opportunity for you to have exchange with the Circular Economy Center. We really value the work that you and your lab are doing. Thank
you very much for the invitation. And yes, is it a public seminar or
Julia,
can everyone assist? Okay.
Yeah, so everyone could attend. It was I mean, subject to them finding out about it through I think LinkedIn and Twitter and the Eventbrite. But it now is going to, I think we do post the videos on the website and we circulate to the attendees. So I hope that's okay. In the chat, somebody asked about sharing the slides, which I guess, given that we have the video, is maybe not necessary. But if you I think it'd be good to share some of your publications about this if you would like to do that.
Yeah.
So if
some of the slides are not published yet, so I would need to filter. But yeah.
Yeah. Okay. Yeah. But if you can, so I guess Ornella will circulate the video, and maybe if you want to send us the publications that you'd like to share, then we can include that, I think.
Perfect.
So thanks everyone for attending as well, and Ornella for hosting. With my interruptions, yeah.
Thank you, Julia, for arranging this, and yeah, thank everybody, and see you soon at another webinar.
Bye-bye.
Bye-bye.
Thank you.